Okay, next we want to find the ratio of the area of these two triangles. Triangle, this guy BOC, as well as triangle ADO. Okay, let's see. So the information about the radius wasn't given yet, so actually we don't really need to use it. What we need to realize is that these are two concentric circles. So that means that the radius here, okay, we know ahead of time it's 3, 3 and 3 there. But because it's concentric, it means that it's directly at the center. So that means that the radius of this large circle, this AO, minus away the length 3, this remaining length, let's just call that a length y. If this length here is y, this length here must also be y. Okay, must also be y. Okay, good. So what can we tell about this triangle with this triangle? They're similar, right? They're similar. Okay, good. So what do we know about the area of similar triangles? We know that the area, sorry, let me just write it down below. We know that the area of triangle ADO, is compared to the area of triangle ABC, small over big must equal to AO over AC bracket square, right? It's the A1 over A2 equals to L1 over L2 bracket square formula. But we know that the AO is what? 3 plus a y. Then the AC is what? 3 y. 2 times of the 3 plus y, right? 2 times of the 3 plus y. Then you square the whole thing. But the 3 plus y, we don't really care about it. We can just cancel them off. So we are really just left with 1/2 square. Okay, so it's 1 over 4. Good. That doesn't answer our question yet because we need ADO compared with BOC, but we are almost there. Okay, let's continue looking. What you realize is that this triangle here, AOB, you split it in the middle with OD. Because of our concentric circles, we know for sure that these two must be congruent triangles. You don't need to prove it. You can just argue by symmetry. Okay, so let's say that this area here was what's it? Let me see. Angle ADO here was 1 unit. This area is 1 unit worth. Then we know that the ratio of area of ADO to area of ABC is 1:4. So what do we know about how the number of units for this area of the ABC? It must be, maybe I'll just highlight it and then I label here, it must be 4 units, right? 4 units. But this 4 units is made up of the 1 unit here plus the remaining part here. Then what else do we know about this remaining part? I hope you can see that there's a line that cuts it. This remaining BDOC region is made up of this triangle and this triangle, right? What do you know about this triangle here? It's congruent to this one. So it means that this must also be worth 1 unit, right? Triangle ODB must also be worth 1 unit. But we know that the entire triangle is worth 4 units. 4 units because of this guy here. 1:4. Sorry, let me try again. So what I mean is 1 unit here versus 4 units for the entire thing, right? Okay, and then this is also 1 unit here because of symmetry. These two triangles, the triangle ADO and the triangle BDO, they are congruent. So what can we tell about this remaining triangle? How many units would it be worth? 4 units. You have 1 here, 1 here. What's the remaining? 4 minus 1 minus 1. It must be 2 units, right? 2 units. Good. So now, can you see? This area is 1 unit. This area is 2 units. So now we can answer the question already. Area of triangle BOC is just 2:1. Okay? That's all. Okay. Should you show more working? I think this is okay already by just drawing the diagram and labeling. Oh, 1 unit, 1 unit, and then 2 units here. It is okay. I think this is quite trivial.